This example problem is called the Peter and strings. Here's a description. So we are given two strings of equal length, and we want to compare them lexicographically. So lexicographically means that determine the order in a lexicon, or in other words, a dictionary. So if you have two words of the same length, when you look up in the dictionary, which word comes first? And the cases do not matter here. And we want to, well, I guess should be print -1 if the first string comes before the second, and 1 if the first comes after the second, and 0 if they are the same string after converting both to, say, lowercase. So just to make sure that everyone understands lexicographical ordering here, try to order these words in lexicographical ordering. So this is beyond this question because this question says two strings of equal length. But in general, we could have strings of different lengths, and we may still want to compute their lexicographical ordering. So for this, the first word in the order is about. So this is a word that comes before all the others because the first letter is A, that's the first letter, and the second letter is B, that comes before the N. And the second word is N. So N and another, they both start with AN, but because this word has nothing after AN, it comes before another. So if you don't believe me, you can find the dictionary and look it up. But I know nowadays it may be hard to actually find the physical dictionary. Anyway, and after N is another, then after that is programming because R comes before Y. So that's lexicographical ordering. Let's first see a version of code solving this problem that take advantage of the fact that the two strings are of the same length. We first read the two strings in, and then answer is going to be our final answer. So by default, it's 0. And then we loop over all the possible indices and look at the character from S and T. We convert them both to lowercase, and then we can compare. So if A is less than T, so then that means we have find the position where the first string is less than the second, so we should return -1. The value should be -1. We assign -1 to answer and we break. So it's important we have to break because we don't want to look further on. Looking further will just confuse us. Otherwise, if A is greater than B, then answer should be 1 and a break. So I left out the else case that happens when A equal B. But in that case, we don't need to do anything. We just keep going and look. So this code works for this problem. Now I want to show another version of the code which also handles the case that the two strings are of different lengths. So in order to do that, I actually defined a function called the string compare that take two arguments st. And basically it will return -1, 0 or 1 based on the specification. So then once I have the function, my main body of my code just have one line. I read in the two string and then I compare them. So here I first convert both of the string to lowercase, and then again I'm looping over the length. But at this point, I have to consider the case that S and T may not be the same length. So I'm looking over all the positions in length S, in the string S. Now, it could be that T is shorter than S. So while I'm looking at the position S, there doesn't exist a corresponding letter in the string T. So in that case, S should come after T because that means that S is longer than T. And so far, everything is the same. Because if it's not the same, then we have returned early. So if we reach this point, this line, it means that so far S and T are the same, and S has more. So then that means we should return 1. So otherwise, we compare SI with TI. If SI is less than TI, we return -1. If SI is greater than TI, we return 1. So similar to the previous version, when they are equal, we don't do anything. We just keep looking. And one other thing that we need to add is when this loop ends, and we haven't returned, that means so far everything we've looked is the same, but we have looked at everything in S. But it could be that t is longer than S. So in that case, we'll just return, no, actually here should be return -1. So that means the S should be come before t. So when we reach here, then that means that the two strings are the same length and everything we've looked are the same, because any other situation we would have already returned. So then that's the case when they are equal. So these comparing string in this way, this is also a fairly useful primitive that you should know how to do. This basic idea of looking from beginning to end and then return the first time you see a difference, and keep looking if they're the same.